Hi, everyone, and welcome. Thanks for being with us today. My name is Bahare Shahsavari. I'm a graduate research assistant at the Minnesota Design Center at the University of Minnesota. Thanks for joining us for another Empowering Small Minnesota Communities project webinar. The ESMC project is a community-centered collaboration with University of Minnesota partners developed to strengthen small communities through the development of resilient infrastructure. Program support includes developing and strengthening project plans for the long-term goals, laying groundwork for proposals and funding opportunities, and federal, local, and state investments. And we want to provide communities involved or interested in the ESMC program with new and accessible perspective on resilient infrastructure strategies. Our webinar series aims to give a better sense of possibilities with examples from professional experiences in the field and to help communities that face similar challenges share best practices and innovative solutions. Today, we present energy efficiency and renewable energy systems with our guest speakers, Kathryn Milun and Dan Handeen. Dan Handeen is a research fellow at the Center for Sustainable Building Research and an adjunct instructor in the University of Minnesota School of Architecture. His work focuses on high-performance buildings that incorporate sound energy strategies, robust assemblies and materials, and a solid understanding of building science principles. He'll be discussing ESMC project in Vegas and Embarrass at the in Minnesota. And we have Kathryn Milun, who is a research fellow at the Minnesota Design Center and Institute on the Environment, affiliated faculty at the Law School, and associate professor of anthropology at the University of Minnesota Duluth. Her work focuses on commons and commonwealth economies, how communities equitably govern shared resources for collective and local benefit. She is the founder and director of the Solar Commons Project, which is designing and implementing a new community ownership model for solar energy. Kathryn will discuss her work on the ESMC project in the Bois Forte Ojibwe communities in the Northeast Minnesota. With this brief introduction, please feel free to put your questions in the chat. We will address them at the end of the presentation. We have Q&A session. So, and also you can feel free to unmute yourself at the end and ask your questions from our guest speakers. In the sake of time, I just pass it over to Dan Handeen. Dan, we are excited for your presentation. Please go ahead.
I swear I know how to use Zoom. My goodness. Well, good to see some familiar faces here. And I don't know, I can't see my own Zoom screen, so I'm hoping everybody can see the presentation okay.
Yes, sure.
Let me know if I need to move or change the view. Thanks for having me. Yeah, the introduction was already taken care of. I'll just get right into it. Please, I guess save questions until the end. I'll try and keep this under 20 minutes. And I appreciated in the introduction that there was mention of specific examples because that's what I'm about to share. So I work at the Center for Sustainable Building Research. I work closely with MDC and CTS for the ESMC projects, and I cannot, there we go. The CSBR works on buildings, so that's why we were brought in for some of these tactical action projects. And why that's important is because Architecture 2030 estimates that buildings emit a fair amount of carbon dioxide, and that is of concern to us. And so that's generally what we're trying to address. And kind of prelude to Kathryn's presentation, we are staunch renewable energy advocates, but the way that we see this happening most efficiently, most effectively, and most cost effectively is to address how much energy the building needs before you start looking at how to meet those needs with renewable energy sources. Mechanicals are important. But in the same way that it's kind of like a renewable energy system is a mechanical appliance that gets added on to the building afterward. Once you have the the enclosure, that is the insulation and the air tightness, the fenestration, solar gain, the usage of natural ventilation, all these characteristics, they start to define what's called the energy signature of the building. And once that's defined, then you start to figure out, okay, what are the mechanicals that I need to meet the demand here, and also what kind of renewable energy systems. So if you have a good energy signature of the building, if it's efficient, then you can get by generally with better performing and generally smaller HVAC systems. So there's kind of a twofold benefit there. And generally our approach to how do we reduce those loads, how do we define that energy signature, that's through controlling heat flow through insulation and keeping our controlled airspace within the building. We've gone through a lot of gymnastics and costs to try and figure out how to, make a building comfortable. And we want to keep that comfortable place or comfortable air where it is. And so that includes air sealing. And air tightness. So I'll be talking about two specific tactical action projects today, one in Vergas, Minnesota, the other in Embarrass. I want to be clear that we worked closely with the utility-sponsored energy audit processes in both of these sites, and so that was really kind of a nice nice collaboration because we were able to focus more on the envelope issues, and the utility-sponsored audits focused more on mechanicals. But I'll talk more about that in just a bit. So I'll start with Vergas. This was also was a collaborative project with all of these different partners, including CERTS, West Central Initiative. But really, our role in this particular project was to look at these 4 municipal buildings that are owned and operated by the city, and they were interested as part of their climate action plan in figuring out how to reduce their energy consumption. And so we went to these buildings and basically tried to look at historical consumption data to get an idea of how were these buildings operating currently, do some energy assessments, and then try and figure out what made the most sense as far as trying to improve their energy efficiency. And I'll go into greater detail on all of those. We also did a fair amount of looking at the utility energy audit to figure out what kind of assumptions were they making in there, and really how did that affect what was actual possible payback in some of the suggestions that were being made, and to figure out whether they were actually doable, right? So again, our focus was really on the shell, the enclosure of the building, so that we can drive down some of the sizing and the cost for those mechanicals. So the utility-sponsored energy audit, their energy analysis recommended the following: install air source heat pumps, fully support that. Install LED lighting fixtures, fully support that. And then there's the part of their buildings, there's a liquor store, the municipal liquor store, and that has a walk-in cooler that's got glass doors on the front, and um, there's basically a heating element in the doors to prevent condensation from gathering on the glass, and so there are more efficient ways to do that. And so that's one thing that I didn't have any exposure to or knowledge about, and so that was great to have the utility be able to identify something else for that. So I'll go into greater detail and not waste time going on this stuff, but really trying to figure that stuff out. So we went up there and we looked at each building. We started with their city office. Can you see my cursor by chance?
Yeah,
Able to.
but
Okay, good.
sorry for interruption, Dan.
Yeah.
Can you move your head to
I
the
don't
right?
know if I can. Let me figure out.
I can
Let's
do
see.
it
Oh,
from
here
my
we go.
phone.
Doot. There. How's that? Better?
Oh, yeah.
Perfect.
Thank
Thank you.
you.
Okay. So now you actually can see my cursor. My big head is not there. Okay. The so the first building we looked at was their city offices, which are the left part of this building that they share with the post office. And this was a an older building, but it had already had some rehab done, and the city offices had just moved in maybe 2 years ago. And they had air source heat pumps as their heating and cooling system. So, and it's an office, so there's not a whole lot of water usage, not really a whole lot of concern there. It was already, pretty well insulated as a result of their rehab, and they had good, efficient mechanicals. So we didn't find any problems with that building, and so we said, great, keep going with that. I will just mention briefly their energy usage. One of the things that we use to measure energy consumption is called the EUI. This is kind of like the miles per gallon of a building, basically a measure of how efficiently can it maintain comfortable conditions. And so this is essentially the KBTUs per square foot per year. But it basically allows us to compare different buildings, and as a measure of their energy consumption. And their city offices at 17.8, which is remarkably low, which is good. It's efficient. So just bear these numbers in mind as we start to look at the other ones. But again, like I said, not a whole lot of concern there. The fire hall was interesting. They've got their primary structure and then an addition that was put on later. And they have some gas heating, propane, and some electric. They've got energy recovery ventilators, which are, it's an appliance that brings in fresh air and exhausts stale air from inside the building. But in that process, it's able to capture the heat out of the typically outgoing air and put it into the incoming air. So you're able to get fresh air constantly, but you're able to conserve that heat. And there are two pretty sizable ones in there, which is important because they've got large diesel trucks that are pulling into here. And so part of the strategy for this is that they're making sure they're getting any of those diesel fumes, sometimes chemicals from any of the firefighting foams
Mm.
and so forth, that can be residual. And so we're making sure that they've constantly got fresh air. But the nice thing here is that they're keeping that energy inside. This is their energy profile. You can see, I mean, fortunately, we were able to get pretty good utility data, which I'll just say, if you're looking at doing something like this for an ESMC project, starting to contact your utilities to get historic utility information, just start doing that as soon as you start thinking about it. It always takes longer than you think, and sometimes it takes a while to get to the right person or the right kind of echelon of who's got that information to be able to be able to provide it back to you. But this is supremely helpful because then it allows us to see, how much total energy they're using and of which type. So this chart shows their electricity consumption, which actually is pretty remarkably consistent, both over the seasons and year over year. This is probably the thing of most interest, though, is these huge peaks defined by this blue line, which is their natural gas consumption. And of course, we can correspond that to the months of the year. This, of course, they're using natural gas for most of their heating in the wintertime, right? We stack those up and we can see their total energy consumption, and they come in at 23.7 EUI, which again is still pretty efficient. But there were still some opportunities. And so we were able to go through with an IR camera and, when there is a difference in temperature between the interior conditions and the exterior conditions, we're able to find places where, there's basically heat conducting or there's hot air leaking out of the building, most typically. And the other way we're able to see this is actually this is some of the soot that we assume is coming from some of the diesel exhaust actually escaping through poor weather stripping around the garage door. And so this was one of the biggest things that we recommended. Um, this had been done, new garage doors had been put in, I think within the past 3 years, and they had actually done a really nice job, except they didn't weather strip or they didn't seal the weather stripping to the structure. And so there were visible gaps along there that were an, obvious opportunity to just put a bead of caulk in there and seal it up. So yeah, that was our recommendation. There was attic insulation in both of the large the bays where the trucks are parking. But there wasn't a whole lot in there, and so we suggested adding some more, again, to keep that heat in there so it's not rising up through the roof, the ceiling structure, and to seal up this attic hatch. That's a common place where there will be air leakage, warm air leakage moving out of the building. And of course, the hot air wants to rise up, and so those attic hatches are a place where there can be a lot of air escaping from the building. So we recommended these actions. They were able to actually get quote. The city got quotes for all of the actions that we suggested. And so that was great, again, because then it was real time. We didn't have to estimate what those were going to be. We didn't have to go try and, make our own assumptions about that. So this was an actual contractor's quote for, oh yeah, you want us to do that? This is how much it'll be. And so then we're able to weigh that against, the effectiveness, how much percent reduction in energy that would result in. Another building we looked at was their event center. This was actually built as a school long ago, and now it has been converted into a community center. They host, big things like weddings and dances, and they're actually a Zumba class in there while we were doing our energy audit. This is their energy profile. It's a little bit all over the map, but this is probably corresponding to when the place is being rented out for events, because they kind of, they turn down the heat or the cool, as the case may be, during those times. And I will say the energy audit recommendations were mainly around their furnaces. There were, I think, 4 furnaces in that building, each kind of serving different zones. And so, obviously opportunity for some more efficient mechanicals in there, but that's still a pretty heavy investment. What we discovered was that this building was built, I think this was 68, if I'm not mistaken. Um, and, really starting to acknowledge, energy conservation strategies in building construction. But they missed this really important detail. They put insulation on the outside of the building here, but we were able to see where there was heat conduction going from outside the building, or I'm sorry, from the inside of the building to the exterior. The other important thing about this was that the ductwork was actually run through the floor, through the slab in this building, which was a common strategy in the late 60s and 70s. We've since moved away from that, mostly because of moisture issues. But this becomes a big deal because we're trying to deliver basically our warmest air at a spot where much of it is just leaking right out into the building. And so that was a nice thing to be able to find pretty conclusively. So here's another spot where that's obvious, right? All of those red areas are the warmest areas where heat's leaking through. We were able to track down some old construction documents and really try to see what was in here. Here's this round thing is the duct work, and then there's branches that come off of here, and there's vents that come up and deliver that warm air. And there is actually a little bit of insulation here on the inside, but obviously there's a fair amount of conduction that can happen through here. So our recommendation was to put 2 inches of foam around the exterior to basically just block that conduction path, right? That thermal bridge. There had been some insulation that was put in up here on the exterior of the above grade walls, but not below grade. And we were able to see that, yeah, actually this would work out pretty well. We could stack some insulation underneath there at this location, and it wouldn't be a weird kind of detail. We did find a couple other little what do we call it? Thermal bridges in different portions, and some other very common like leaks around the doors and so forth. We did find this very interesting thing, and this is not really anything to do with energy performance, but part of the cool part of being, an energy detective in ways. We were looking at this. This was the south wall of the structure. And that's what it looks like. But then when we put the thermal camera on it, it had all these spots in here, and we're like, what is this? And of course, one of the city administrators that we were working with was like, I actually went to school in that building, and they used to have like a 1960s stained glass kind of pattern, of these colored glass units in the south wall, and they just covered all that up with the wall, I guess.
Excuse me,
Again,
Ken, as you
yep.
requested, we just have 5 minutes.
Okay, I'm gonna go really fast. Anyway, there's some cost estimates for that. We also were working with a solar contractor to figure out what would be the right size of solar to put on this building. They were interested in putting solar on here. Nice, huge metal roof and actually, great candidate for solar to help offset some of their city electricity use. And so, this helps us understand some payback. But one important thing here that I think can be commonly missed is that they have most of their heating relying on natural gas here. So while PV arrays are typically sized based on, there are certain incentives, that primarily Excel puts in place that are based on your historical electricity consumption. If you're moving from natural gas heating to electrical heating, that's going to dramatically increase your electrical consumption. And so when you're sizing for something based on historical electrical consumption, it may not really be big enough to meet your new electrical demand. Does that make sense? Um, so this is a great array to meet their historical electricity consumption, but obviously the PV won't offset any of the natural gas consumption. And if they're moving toward heat pumps or electricity sources of heating and cooling, they might find that there's going to be considerable cost still for their electricity because their PV system, or maybe they'll need another one at that point, right? We'll just put it that way. This was another building. I talked about this. Actually, this was a historic creamery. There had been already some energy improvements done to the facade of that. We were able to find a couple leaks, especially this elevator shaft up at the top was basically a big chimney. A lot of heat was rising up out of there, and so we recommend tightening that up. I want to just touch on this one briefly. This was all of those buildings overlaid. And so this shows us, obviously here's the blue one is the event center. They've got those big spikes from natural gas. Here's the liquor store, the orange one, the fire hall. They've got their big spikes during the winter time. But then I want to point out the city offices here, way down at the bottom, right? So really the point of this chart is to say, really put your efforts where you're going to have the most effect. And so concentrating their efforts on the fire hall and the event center is going to have the biggest overall impact. And so, obviously don't spend money on trying to make the city offices more efficient if you're concerned about your entire, cost portfolio. I'll just touch briefly then on this other project we did in Embarrass. They've got this historic timber hall. This is apparently the largest enclosed uh, log cabin type structure in North America. Um, it's something like 40,000 square feet enclosed, pretty sizable. This is what it looks like inside. It's literally just a huge open space. We went around and even though they just had brand new doors put in, maybe like a year and a half ago, they weren't the exact same size as the old doors, and they didn't do a great job of tightening things up around them. So we were able to find a fair amount of leaks around them. And as you might expect with log cabin type construction, they did put what's called chinking. That was just basically layers of fiberglass insulation in between each log to try and prevent airflow from moving through there. But wood changes over time, right? It's obviously going to shrink and swell a little bit, but primarily shrink in this case, which opens up gaps in between the logs and allows air to basically escape from inside. The other interesting thing is that they've got these kind of stabilizing walls at certain points about, I guess they're quarters of the building. And because logs will check radially, that means this kind of this wedge-shaped opening that appears in them, that creates this, basically an air gap that's moving continuously from the interior to the exterior. And so finding places where those are happening and then making sure to tighten those up. There had been some air sealing done previously, but it hadn't been done well. This was really kind of pointing out the obvious places. There's a large radiant floor system in this. That's the heating comes from electric resistance wiring that has been put into the slab in the floor. And we went up there in, it was basically the summertime when they shouldn't have had the heat on. And the thermal camera allowed us to see this really weird warm strip that was running the entire width of the hall. Nobody really knew why it was there, but obviously it didn't need to be on. But we were able to then go into I don't know if you can see this way maybe. We were able to then go into the electrical panel and figure out which of the circuits was on. I mean, obviously the warmer one is going to have more electricity going through it. And so we were able to identify that, turn it off, and save them some electricity. Couple quick things related to, our energy audit versus the utility energy audit, one of the big things that they're concerned about, they don't have any cooling right now at Embarrass Timber Hall, and they're of course seeking some more energy efficient and frankly quieter heating strategies. Right now they keep that electric floor at kind of a baseline 55 degrees, and then when people are in there, they add a whole bunch more heat with these large propane powered garage type heaters. And when those kick on, you can barely have a conversation in this open, very resonant space. And so they were looking for some quieter options. The utility recommended air source heat pumps. That seems like it could be a really good strategy to meet some of those cooling requirements, and being a quieter option. Um, so next steps, find an appropriate air sealing material. I think they've found that, there's different types of it's almost like a foam, but not quite, for actually doing air sealing between that log type cabin type of structure. The other thing I'll just close with was that they had already been working with an architecture firm based out of oh, forgive me, I think they're based out of Virginia, Minnesota, called DSGW, um, that had done a couple schematic designs for their building. And one thing we were able to do with help from some of the ESMC RAs was to help visualize what some of these changes would look like, beyond just the floor plan, because they were making decisions just looking at the floor plan, and not everybody reads those kind of equally and understands this kind of spatial dimension. And so this is as built, this shot right here, and this is what the suggestion was. Primarily, this is done to protect this wall because they were getting a lot of rot on this wall, quite frankly. These logs were starting to suffer, and so a simple way to try to protect them and stabilize them was to really just extend the roof over there. But what does that actually look like? So a couple different shots, and there's some interior moving around too. So that's it. Summary, lots of places for energy savings, but it can definitely go beyond just replacing appliances and HVAC equipment. Some of these can be cheap, like air sealing especially. Maybe it's just walking around with a tube of sealant, or caulk gun, or spray foam. Um, the other thing about this is that a lot of the time these improvements are permanent. They'll continue to have cost savings and energy savings over the life of the building. And of course, they'll help with thermal comfort. Generally, people are more comfortable when there's not cold air drafting in around the windows and parts of the walls. So that's it. I'll turn it over to Kathryn, and
Thank
look
you,
forward to any
Dan.
questions at the end.
Yeah, thank you so much. I appreciate your work and project. That was great. And Kathryn, we're looking forward for your presentation.
Thank you. All right, I'll go ahead and share screen.
Mhm.
Here we go. And I'll put this. Okay, get rid of my, hold on one second. All right, great. Thank you, Dan, for starting us out. And as I told Dan, I work with solar infrastructure. Before I start talking about solar, I always try to remember that we have to talk about the holistic context of solar, which is building building energy use, and the first step is always to be able to find out where how to reduce that first. So thanks, Dan, for starting us out. So I'm going to talk about the ESMC projects in the 1854 treaty area that I worked on, and I'm just going to this is over the last 2 years. I worked with these communities in the treaty area of the Lake Superior Ojibwe tribes, and we focused on the infrastructure needs for food and energy sovereignty. So it's a different kind of framework for infrastructure. There are lots of best practices and solutions that I'll share from our work, but today I'm going to focus on how we use solar energy infrastructure to build local resilience and to empower community practices that localize healthy food ways, which encompasses many solutions to many problems. So first, I'm going to note that I'm an anthropologist and that my research area focuses on how people share things, how they manage shared resources from a village water well to a regional watershed. So from an anthropological perspective, infrastructure includes the technologies, the practices, values, and the social rules that people deploy to support a way of life. So when people build infrastructures to sustainably and equitably share a common resource, in English, we've historically called that shared resource a commons. And increasingly, I hope you're hearing the verb dominating to describe this kind of sustainable, equitable, bottom-up social practices and rules that local communities are creating among their neighbors, with their governments, and with their private local businesses to manage together their shared resources. The Ojibwe themselves have many words, other words besides to talk about doing things in a good way. And when we work together in using this ESMC process, I'll talk about, we found ways to connect the solar infrastructure to serve the needs that the Ojibwe communities had, and also with their local allies. So let me figure out how to do this. Hold on. All right, so first let me talk about some of the project areas. So with MDC, we did mapping with the community about the areas. Here you see the 1854 treaty area. So the tribes here also have off-reservation rights for using and stewarding natural resources, fish in water, forests, wildlife, etc. So again, here's the area itself, the project area. Here is the Bois Forte Reservation is has a small reservation on Lake Vermilion, and then a much larger one here up closer to the Canadian border. In these areas also, forests have been returned recently to the tribes for their stewardship from the state. And the same is another tribe we worked with closer to Duluth here was the Fond du Lac Reservation here, also have recently had their forests returned for their own stewardship. So we have tried to also encompass that in what we were doing. Let me see. So in terms of project needs, let's see here if I can, whoops. Sorry, here. Sorry, I haven't used this. So the disadvantaged communities overlay, this has to do with income level in these communities. So you can see that the dark blue and the darkest black, does encompass the reservation areas as well, importantly. In terms of brownfield sites that we were looking at here in one of the areas in Mountain Iron, city of Mountain Iron, we were working with, and also down here in the Fond du Lac Reservation. So we wanted to think about solar infrastructure using brownfield sites. The other key thing here was drinking water. And so if you're looking at drinking water non-compliance in this area, up here by Bois Forte, there's a very one of a large area of this of incidents of non-compliance, and there's some very serious and important work going on here. There's mining in this region, and so in particular the sulfide content of the water from the mining practices is an area of huge contention, and we want to work with, but it's very important to understand that right now we have a legal mandate for the approved sulfite content, 10 parts per million in the water in this region, which hasn't been sufficiently practiced. And so just even last week with the Minnesota Pollution Control Agency, there was a large meeting up in Virginia about this, efforts to raise the content of that. And that content comes from Manoomin, the wild rice in this region, which is the only region in the world where this type of wild rice grows. It's a sacred food for the Ojibwe, and University of Minnesota Duluth has done a lot of research on how much sulfide can be in the water in order for that the wild rice or the manumin to thrive, and that is the standard right now that we're struggling to keep, and it comes from that food source. So finally, this is where food deserts are in this region. So again, you see on the tribes where I'm working with in the blue areas here, where the dots are here, where the tribes are, the reservations are. So you see large food deserts in this region. All right. This is the team that we put together here. And you know, and what we did was we did a kind of need assessment here, working with all of these entities and creating partnerships with them. And once we had that mapping of needs, etc., we looked for grants that we could apply for to fund that. We did budgets for it. And then we actually wrote the grants together with our community partners. We wrote several grants because, you know, we were trying to take advantage of the, of this historic moment for infrastructure with the Biden administration's large infrastructure act. So we were able to write a $20 million a grant proposal and to take care not only of so again, focusing on food and energy sovereignty, but with several other things. And one thing we did add was also housing. And we were able, because these grants could go up to 20,000. So we also were looking at what the tribal housing needs were there. And we were able to think about the forests that had recently been returned and what kinds of local economic structures could be connected to this infrastructure needs. And so we thought about wood-based housing structures that could be built, and we created apprenticeship programs, and we designed a kind of apprenticeship program to teach people there with the local community college to do that kind of building using their forest products. We also did this with solar. We included with solar wood racking systems and a feasibility study for how their local forestry services could be used for wood racking instead of aluminum racking on solar. And that kits for wood racking could be not only used for solar in that region, but also as a small industry project. So again, we were very integrative in our thinking of how infrastructure, in particular solar infrastructure and others, could be part of building this economy. I'll just real quickly show you how the solar how we use solar infrastructure then and connected it to this the other needs. So the idea is this, very simply here, once you have solar on a building, you know, this is your bill. Without solar, you know, your electric needs over, this is on the bottom here, you see a 30-year period, you know, your bill 3% at least a year of increase on your bill when you don't have solar is going to increase over the next 30 years. We know right now, I think in Minnesota and other places, we're increasing at 6, 12, in some places 18% a year on our electricity rates. So this is going to go up for sure. Again, this is a 30-year period because the solar infrastructure, the panels themselves will last for that long. They have warranties up to 25 years. So thinking about all of solar savings that that will happen over that time, and thinking about that as a form of commonwealth. So it comes from the sun. How is it a form of commonwealth? So if these are your electric needs, this is what your new electric bill will be over that 30-year period. You can pay back the solar infrastructure here, then have your bill be at this level. So you have all these savings here. Now, if that, so what the Solar Commons project is to look at that infrastructure and have neighbors partner together with a local building owner who will agree to share some of those free solar savings once the infrastructure has been paid off. So again, how does that work? We use a kind of conceptually, we have, think about the sun as a form of commonwealth. These are now we're talking about behind the meter. So it creates again, not going directly into the grid, but savings for a host, either, on the roof or, outside, but fed into their meter. You have to create a governance structure for a local community to do this together. And we have a legal team that does that to create a solar commons agreement and with trustees. So those savings will go into a trust fund, and then the community will have also a governance structure, peer governance, to use it over 20 to 30 years for community needs. This also requires, as we discovered, a dashboard that will help make transparent and accountable what the community is doing. So in this case, we can have a direct feed from the inverter into the dashboard and know exactly how productive that solar array is, how we can also show how much solar savings there is on the electric bills, and the community can report on this platform what they're doing with an annual distribution of this. So I want to say that this is we talk about what's going to happen with jobs and various other things with AI and everything. The direction we are heading with automation in many areas of our economy will require something like a universal basic income. And I imagine that my audience knows what that is. A solar commons would be to use this solar infrastructure as a kind of community basic income. So in our case here, we were thinking of how doing all the calculations to understand how much savings over the period of secure warranty of the solar panel could be put and used by the community for stable funding rather than continuous grant funding for things, in this case, food sovereignty work to build food sovereignty in the region. So I'm going to talk about a few of the projects and the partnerships that we had. So there in Mountain Iron, we have the state's only solar panel manufacturing company, LEN. And their first factory is there in Mountain Iron, which is about 40 miles from the Bois Forte Reservation. So the CEO of LEN has worked with us on this, and they would use their own solar panels, and they provide them at zero profit at cost to the project. And they at 500 kilowatts, they would use it to power their factory and deduct the savings after costs and send that to food sovereignty work on Bois Forte Reservation. So in this case, this is for this would be about $65,000 a year that could be used to support a food sovereignty coordinator that doesn't yet exist, and other food sovereignty work. So this is we have an agreement that's at this point it's an MOU, but we are right now completing that actual executable agreement that would allow us to do this with solar. And we applied for funding in several fund sources to do this that we hope to be successful on. We also had let me see. Whoops, I have to go back here. We had the other one we did have on our grant was with the tribe itself. So the tribe itself, the Bois Forte tribe, would put 500 kilowatts of solar plus storage on the casino and some other large buildings. And they would use that to specifically using solar commons agreements, fund their food sovereignty coordinator work. So there again, they would be using tools, legal and peer governance of the Solar Commons project there on the tribe within a tribal sovereignty context. So the other project that we added then to this was the public commons project. So here is the city tower, and which is right on land, and then the Vermilion Preschool, and the city tower owns that building. So we are in the process of applying for the statewide solar on public buildings grant, which is a way to take advantage right now of the of what's left of the credits that are in the infrastructure bill for solar. Right now, we have a 30% credit. It is a direct pay from the government for solar projects that is in place until December 31st. The state of Minnesota is pushing out $14.5 million to public buildings that will put up solar, are able to put up solar in this period. These projects can't be over 40 kilowatts. So this is a 40 kilowatt solar commons. It's going to be on the country school. We've done a lot of work on this already. We have our plan, and are just in the process of pushing this through. In this case, the distribution will be about 40 kilowatt system plus storage. We hope, but this will be between $6,000 and $8,000 a year of annual distribution. And in that case, we would use it with something called the school participatory budgeting. So this would be a way to have kids themselves and community members part of the governance of those funds that come out. And the kids in the school would also be creating projects and having voting on the projects by the school and the community. They'd do the budgeting process for a project, working within the budget they had from the solar commons distribution, and then building that. We also created for kids, in this process, we created a game to learn about solar and the building of a solar commons as integrated with nature commoning. And so, again, we have the framework of food sovereignty here that we want to serve, which is vast. It requires a lot of education and also practical and cosmological values of the Ojibwe into the relocalization of food and their foodways. Up here also is I think Jonay is on this call, so this is something that Jonay, my colleague at MTC, has helped work on. This is our first dashboard that would show solar radiance. It would show how we actually transparently showed how much money was coming into the fund. This dark green is the market value. The light green is would be the solar commons going to the trust. The pink here is how the beneficiary community would annually report with pictures and other things, what they did with the money. But there's also a way here to show the relationship between this infrastructure and air quality. So this too, you have CO2 that is avoided, but also we'd like to bring this into the water issues here. Monitoring that's being done on sulfide in the water can also be put in, and this is for the dashboards we're building up here in the 1854 treaty area. We want to put that water monitoring feed into our dashboard. So we'll have air, water, and sun. And we, are, again, is the larger cultural picture of integrating our infrastructure with our ecological infrastructure. So again, this historic moment that is now gone, and as of December 31st, that we're really trying to capture. This is just some numbers, so you can see that with this infrastructure, this was just for the state of Michigan, but this really was the largest infrastructure investment in U.S. history to address climate change. In Michigan, they figured it was about $47 billion that was available for climate resilience, $65 billion for clean energy in the grid. So this is the funding source that we are working so hard to try to before it is gone. The final thing I want to say here is that the financial benefits of solar PV can be viewed in several ways. Obviously, there's industrial scale and industry and investor-owned solar. We can continue, and we will continue to be doing solar in this way, but we don't have yet sufficient community scale and community-owned solar models. So we hope that being able, with our ESMC communities in the 1854 treaty area, to be able to show how solar can be owned and become an economic engine for other values and needs of a community. This is right here, one of my favorite pictures. The Solar Commons Project had this requested that a tribe in India show us what it was like in their village when they got solar. And this is what they depicted with their indigenous painting style. Here's the solar over here. It is as large as this beautiful, I'm going to put this up, rice plant right here. This is the sacred rice plant of the Varli community. And so the solar and the rice plant are absolutely interconnected. Here is all the other activity that this ecological and mechanical infrastructure interconnects and creates a way of life around. And again, that is really what our project is trying to do, is to really make that connection for people in their minds, in their hearts, this interconnection between, as I say, a kind of commoning that earth systems do together, and then the building for electric systems with solar, the kind of commoning that we can now do. So I'm going to stop screen share. I hope I didn't go over too much, and take any questions.
Thank you so much, Kathryn. That was great project and information. I think we have just 6 minutes for Q&A. And if you have any questions from Kathryn and Dan, Tom.
Yeah, Dan and Kathryn, thank you both for presenting. I kept thinking as you were both talking about how, for example, Kathryn, your thinking might land in a place like Fergus Falls or Embarrass. In other words, are there ways for these ideas of solar commoning to go beyond tribal communities to become more widespread in non-tribal communities? And Dan, how do you think Fergus Falls or Embarrass leadership would respond to some of Kathryn's ideas?
Wow. So I'm going to start real quick, Dan, okay?
Sure. No, go for it.
Yeah, we actually do have a Solar Commons project in Tucson, Arizona that's been going since 2018. So we do know how to do this, starting with a community. The project itself always works with, as we're building the tools for this kind of work. We always start with underserved communities. So we make sure that the tools we build can be used by them efficiently. So the small Minnesota communities and their needs, I think, are perfect for this, even though the one in Tucson is urban, etc. But it is to serve needs of an underserved community. And so how we do know how it can be used there. I think that the school-based one that we are doing is going to be really important. And just real quick, Tom, that we did the anthropology program here at UMD and the engineering department, mechanical engineering on the Twin Cities campus. Together, I've worked with the undergraduate students, the seniors in both places, and with my colleague Uwe Kortzagen, who's a professor of mechanical engineering. We entered a Solar Commons project for the rooftops of all campuses in the state of Minnesota, all university campuses, to meet their solar mandate and have Solar Commons carve-outs of 500 kilowatts that would provide, and the engineering students did this, and they worked with the governance piece, with anthropology, to provide funding sources for 20 years in agreement with their local communities. So this could be through schools or others, communities of need in their neighborhood. They could be that kind of a partner. They could put their dashboard up in the university library. Everybody could see exactly a more integrated economy that we actually can be decision makers in having built. So those are my suggestions. But Dan, I'd like to hear what you think of Ferguson.
Well, it might be obvious, but I think it really depends on the place and the capacity that they have. So Kathryn might be able to speak specifically to Embarrass, because that was one of the places that had been you know, potentially looking at doing a solar commons project. I think the problem there was that there's just limited capacity. They just don't have that many people in town. Embarrass is literally a post office, a credit union, a convenience slash gas store slash liquor store, and like a little historic site, and then the Timber Hall, which is like their only community event center. And you know, so there's like, it's not even a town really. There's just
Right.
limited capacity. And then so much of that then is tied to availability of funding. And so we were able to really leverage some of other ones just didn't work out. But I will say for Vergas, which is important, I thought at first time I heard it, it was Vergas as in Fergus Falls, but this is a different town. This is Vergas, which is up near Detroit
Oh my
Lakes.
gosh.
Yeah,
Burgess.
right.
Oh,
Yeah. Totally different town than Fergus Falls. But they have an interesting kind of demographic, which is a lot of people that come who have basically lake houses in the area, right? And so while there's a lot of money generated in property taxes primarily, there is a pretty big discrepancy between political and kind of, you know, social engagement and motivations of the full-timers versus the part-time residents. So it was interesting to try and navigate that and our contributions to talking about energy efficiency without talking about, you know, things that might have provoked responses like climate change and carbon, that sort of thing.
right.
So,
Yeah.
you know, yeah, and I think a lot of people, especially, you know, I mean, I don't want to generalize too much, but it seems like people who have a lot of money are much more comfortable with an individualized sort of approach to how they solve problems. Whereas what you're talking about is inherently a community-based solution. And so that would definitely correspond more with the kind of the local
Right.
folks.
You
Yeah.
know, I'm thinking of Andrew Yang in 2016, who was there on the platform telling everybody, this is what's coming for our economy with mechanization. We are here with AI. We are here right now. And our computer science students that, you know, would build software systems important for all this infrastructure. We are building in the energy transition. They are out of jobs right now. They are no longer, you know, we're facing all of that in our classrooms. But so I will say that again, Andrew Yang, universal basic income. This infrastructure, wind, solar, the energy infrastructure that's coming, hopefully we do this. We're talking about billions and billions of dollars that will be in savings that people have by not paying those fuel costs and everything else. So this does create an opportunity for those savings to become a type of universal income. Some of the people I work with in California on this, and this can even be individuated and not a community-based kind of thing, in the sense that in California, they're talking about a solar commons form that would be you're born and you get 10 panels in a large solar array in the desert. And then starting in year one, you've got 20 years on the warranty of a income of $1,000. That's for 10 panels, all calculations done. $1,000 a year for 20 years as a universal basic income. So we have to start thinking about the ways in which we're going to stabilize our economy. I'll say an Embarrass, if I could just finish. What the community was interested in Embarrass was they made a trip up to Finland and they saw how the community center in Finland was able to provide community programming for the community, and so they thought the Timber Lodge do that too. So once they stabilized, you know, all the costs and things like that, they thought of using solar and a solar commons projects to what? To fund a salary for a programmer, community programmer there for the community, because they didn't have the funds in the public domain. So yeah, so that's how they thought they could use it. And you know, I think there's a lot of creative thinking, and I'm really looking forward to MDC and the work we all do together at the university to be able to help provide, you know, what are the tools that communities are going to need to start working with their new infrastructure, energy infrastructure, in this different economic way.
Mhm. Thank you so much for
Can I
your
ask one
response.
more question? If Kathryn, if you don't mind sticking around, I'm curious about, we're working with so many communities, as Dan had mentioned, there's low capacity and limited funding, and now even more further limited federal funding. And I'm just wondering if there is a community that we would recommend the Solar Commons process. How would we go about doing that? Would we direct them to the Solar Commons project? Is there some type of manual or project pathway that we can share with them? Just curious.
Well, I could say really quickly because Jonay is here right now, and that is that Jonay has been helping me work on this for several years. That is, we need a manual, and we need and the legal agreement and the peer governance dashboard stuff. These are tools, 3 tools that it's our aim is to get those out so that people can do it themselves. And we are very committed to having these be open source. And right now I have a CERTS grant and some other things to work on just on those tools. And the demonstration projects that we have up in Tower and in Tucson and other places, they'll be best practices, information for people, but people should start doing this themselves. Communities should start doing themselves. And this is a role for the university. I would love to see our university be, a key assistant for communities in getting a hold of this stream, this income stream, for this long-term type of work that community building is and community wealth building.
Can I just say, bridging Tori and Kathryn, what you were saying, I'm really intrigued, and Tim and I have been talking a lot about the role of the regional development organization and bridging the capacity too. Might there be a Solar Commons service kind of branch of a regional development organization that helps these cities in addition to
I am so excited you said that. Actually, that is the place where we have been thinking of as we're doing the dashboard work. If there's a kind of centralized platform and just some funding that has to be there for, say, the dashboard platform and things like that. Could it be RSDP? Could RSDP have some resources that would help people do this? I think that's exactly the place for it too.
Because there's this gap of capacity, even gap funding for the public solar grant, that kind of thing.
Right.
There's just this missing link.
Absolutely. Absolutely. Right now, we're doing the statewide solar. I should just throw this out there. I think it's really important. One thing we did with that to decrease the cost for community, usually have to go through a bidding process. Everybody apply for these statewide solar grants, and we have 2 months to do it right now. And I would say, Tori, for communities are going to try to get that money. I'm actually writing the grant with Tower, so I understand what it is. But one really important thing we did is that we joined the Solar United Neighbors Co-op movement. It's a national movement. They have a branch here in Minnesota. We joined them as a co-op member and went through a bidding process for our solar installer to find our developer collectively. And then that will qualify now for having fulfilled that process, which takes a super long time and is a waste of resources for many of our solar developers to have to do this over and over again. So we are finding some places in the bureaucratic management of the money that needs to go out there to save money, time, and everything. And this is urgent now, with this new funding things, because on public buildings, $14.5 million, 40 kilowatt systems. The solar developers want to do this work. And believe me, that statewide solar program grant is so onerous. It's really hard to work your way through. And there are some things we're learning, about how to do it and save money and time. So, maybe RSDP is going to be the place to push that information out quickly.
Thank you so much. That's really interesting topic. I wish we could continue more on that. And I'm really enjoying learning. But we already passed the time. I appreciate your time, all of you who are participating, and our guest speakers, Kathryn and Dan. Thank you so much for your presentation. It helps a lot. Your project's gonna help a lot for the communities. And I wish we could, I hope that we could continue discussing this in another webinars as well. So I hope that everybody have a great rest of the day. Enjoy this weather and stay healthy.